Hi. Today in this session, I'm going to discuss magnetic circuits. Now let us see what is a magnetic circuit. First, an electric current is made to flow through a conductor. It creates magnetic field. That is, it produces magnetic flux lines. Here, if it is a current carrying conductor, it shows the direction of current as I amperes. Then whenever a current carrying conductor is carrying some current, it produces magnetic flux lines. So every current carrying conductor is able to produce a magnetic flux on magnetic field. And such magnetic flux lines, it is nothing but lines of force, is denoted by the symbol phi. And unit for this magnetic flux is Webers. So here how to know the direction of magnetic flux lines in a conductor, which is indicated by right hand thumb rule. So here, for example, if we carry a conductor with our right hand like this, if we carry a conductor with our right hand, then this thumb indicates the direction of current. Then this folded fingers like this, then this folded finger. Here pen is the conductor, and if we hold this pen with our right hand, then this thumb indicates the direction of current, and our folded finger indicates the direction of flux. So as per this right hand thumb rule, we can identify the direction of magnetic flux lines according to the direction of current. So how the magnetic field is produced? Now here it is an iron base over which a conductor is wounded like this. Then this conductor is excited by some source which is able to carry some current of I amperes. Then this current carrying conductor is able to produce the magnetic flux lines, means which is going to magnetize this specimen of iron piece, thereby producing the magnetic flux lines, and these magnetic flux lines are passing from one end of this material to the other end like this. Always these magnetic flux lines forming a closed path. So here the magnetic flux lines were leaving the bar is called north pole, and these magnetic flux lines are entering at the bar, it is called south pole. So here always a current carrying conductor is able to produce the magnetic flux lines, and these flux lines are flowing in a closed path, and they are leaving at north pole and they are entering at south pole. So this arrangement is called a solenoid. Solenoid is nothing but an iron piece over which a current carrying conductor which carries some current produces magnetic flux lines. Simply, it acts as an artificial magnet by producing north and south poles. So in this way, instead of permanent magnets, we can use this type of artificial magnets. Means we are creating artificial magnets using this solenoid principle. So here we can use these magnets in any shape, which is a straight magnetic bar or which may be a circular shaped magnetic bar like this. So here it is a ring shaped magnetic bar which is surrounded by, here this circular shaped iron piece is surrounded with a current carrying conductor. Then it carries some current, it produces magnetic field throughout this circular shaped ring. So in this dotted line which shows the direction of magnetic flux lines shown here. So like this we have different shaped magnetic circuits. So now magnetic circuit is nothing but the closed path. A magnetic circuit is nothing but a magnetic piece which carries the magnetic flux lines. Magnetic circuit is a closed path which carries magnetic flux lines. Here now let us see some of the definitions here. First, let us see what is magnetomotive force. Like EMF in electricity, we have MMF in magnetic circuits. There, EMF is the electromotive force in electric circuits which causes to circulate some current, which is the driving force to move electron from one point to other point of the material, causing electric current. Here in case of magnetic circuits, magnetomotive force is the force which is nothing but the tendency of producing the magnetic flux within a current carrying conductor. Means in electric circuit, how the EMF is going to drive the electric current. In magnetic circuit, MMF is the driving force which drives the magnetic flux in the magnetic circuit. So EMF is the driving force in electric circuit. MMF is the driving force in magnetic circuit for the production of magnetic flux. So here usually this magnetic force is denoted by the symbol. MMF is denoted by the symbol F. So unit for this magnetomotive force is ampere turns. So here mathematically this magnetomotive force is denoted with a circular ring and which carries some current carrying conductor, and it is able to produce the magnetic flux lines. This red lines shows magnetic flux lines. So here if this conductor is having certain number of turns of N turns and it carries a current of I amperes, then its magnetomotive force of this conductor is N into I, where N is the number of turns, it is dimensionless, and I is the amperes current. So product of N and I is known as magnetomotive force. So MMF F, either it is denoted with capital F or small f. Mathematically, magnetomotive force is denoted with the product of current and number of turns of that coil, which is having the unit of ampere turns. So how much magnetic flux is produced by this coil is depends on these two parameters, N and I, and whatever the flux produced, and that flux is passing through this circular ring having a radius of R, where the flux is denoted with the symbol phi. So here the MMF is similar to EMF in case of electric circuit. There EMF drives electric current, here MMF drives magnetic flux.